Hi, my name is Glenn Weinreb and I'm the CEO and founder of GW Instruments. I'm going to talk about our company history and review how GWI got started. Over the last 30 years, we have been designing and manufacturing data acquisition hardware and software products for Windows computers.
I started my data acquisition career at age 9 in 1973 when I developed a data acquisition system for the school science fair. I used parts primarily from a toy erector set to build a strip chart recorder which measured force versus time from a small model rocket engine that burned solid fuel. A coffee can with a piece of white paper taped to its outer surface rotated at approximately 1 revolution per minute while a magic marker drew on the paper. The marker was mounted on a little cart that slid back and forth. The right side of the cart was attached to a spring and the left to a small model rocket engine. The cart slid to the left as the engine pulled. The result was a graph that showed the engine turn on, run for a while, and then turn off. Today, our techniques are more modern, yet in many ways we are doing the same thing. Later, during the summers of 1977 and 1978, I worked full-time every day at my father's laboratory at the University of California, Berkeley. I did electronic technician work, which involved soldering wires and doing repeated measurements. I was bored at home, and this seemed better. Also, this is when I sold my first instrument. Some guy visited the lab and needed a custom device that had been designed and built by the lab. The lab did not sell gadgets, they only did research. So someone in the lab blurted out, "Hey, Glenn could make this for you on his own time for $300. And there I was, 13 years old, smacking gum, wandering around the lab, not paying much attention, yet later realized that I had just formed a company. When the customer placed his order, he asked for my company name. I told him I did not have one and asked why he cared. He said he did not care, yet needed a place to file the paperwork. So I said, "What about GW Instruments?" He said that was fine. After I received the order, I phoned a distributor to buy electronic components. I gave them a list of parts, and the saleswoman asked for my purchase order number. I told her I did not have one, and asked her, "Where do I get that?" She said it could be any number. So I said, "What about 1, 2, 3, 4?" She then wanted to know how old I was. I told her, with authority, that I was 13. She laughed and told me she would ship only if I had a note from my parents saying they would pay if I did not. Over the years, I was able to give them a lot of business. This $300 device was a voltage amplifier where the output voltage was the logarithm of the input voltage. I did not understand the internal circuit, yet I could assemble it. I sold about 50 of these between the age of 13 and 20. After each $300 sale, I would go to the bank, cash the check, and hang $20 bills on an internal clothesline for several days for fun. Also, to treat myself, I would skateboard to the local ice cream parlor and buy a $3 ice cream soda and grilled cheese sandwich. That was my reward for work. I never spent more money on myself. I'm a bit like a Buddhist. I prefer to save than to spend. Then, when I was 15 years old, I was working during the summer at my father's lab at the National Radio Astronomy Observatory in Charlottesville, Virginia. At the time, they were working on building the VLA, which is 27 telescopes in the New Mexico desert. My father was in charge of electronics there, and they needed a data acquisition system for their $20,000 Hewlett-Packard desktop computer. I knew how to do digital design by this time, yet not analog. So I did the digital and the software, and my father did the analog design. This is a photo of my father in front of the system. The data acquisition device is at the bottom of the picture. Then, when I was 16 years old, I did the same for the Apple II computer, shown here. I sold 2 of these for $3,000 each to the University of Italy in Bologna. An NRAO made 7 of them, many of which are still running 30 years later. This is the Apple II computer with 16 kilobytes of RAM memory, which is much less than the gigabytes that we see today. Well, in high school, I built a computer that featured a 6502 microprocessor that could do simple text editing and printing. I designed the video board from scratch and wired it by hand. I also rebuilt a 1973 Datsun automobile, which I drove for about 10 years. It was here that I learned about mechanical systems and materials. I was in charge of photography for my high school yearbook and newspaper, and this enabled me to learn about writing, photography, marketing, and advertising, skills that would later prove invaluable. This is one of my favorite photos that I took while in high school. By the time I was 18 years old, my test scores and grades were not 100% top-notch. Yet MIT liked that I was a builder of gadgets, and they accepted me into their electrical engineering program in 1982. Here is a photo of me on the phone when they called. I said, "Are you sure you got the right guy?" They said, "Yeah, we got the right guy." During the summer, after my sophomore year, I was working at a summer job for Sperry Marine Systems. They were waiting for a big government contract to come in and did not have work for me. So, to combat boredom, I designed a data acquisition system for the Apple Macintosh computer. When I went back to school, I placed an ad in a magazine, got lots of response, and started selling these $2,500 gadgets out of my dormitory. I shipped about 100 of these during my senior year in college. This is our factory in the dorm, and this is our research and development office. When I graduated in 1986, I wanted to go to graduate school and had been accepted into the MIT graduate program. Yet I was inundated with people that needed stuff. So I decided to focus on the stuff and put graduate school on hold. Suffice it to say, it is still on hold. In the early years, after school, we focused on making hardware and software products for Macintosh computers. We had two primary software products. One was called SoundScope, and the other was called SuperScope 2. SoundScope did sound analysis, and SuperScope 2 did waveform acquisition and analysis. In 1993, we had a 56-page catalog that described a variety of hardware and software products that we had developed, and we sent this to customers via snail mail. Today, we have no printed materials, and everything is at our website. This is what happens when a 27-year-old owner of a company is left in the office alone at 3 a.m., unsupervised, with PageMaker and clip art software in front of him. In 1994, we promoted the concept that in the 21st century, computers and instruments will become one. This was a popular theme that summarized our work in the 1990s. In the year 1999, we transitioned from Macintosh to Windows computers, and we now exclusively design and manufacture Windows hardware and software products. Our primary hardware product is a small USB-based card cage that accepts a variety of cards which directly attach to sensors. Each channel can measure a voltage source, current source, resistance, thermocouple, thermistor, RTD, strain gauge, or load cell sensor. We specify absolute accuracy when attaching to these sensors, and our prices are excellent given that we provide versatile inputs with high accuracy. The method that we use to obtain high accuracy is to place the noisy microprocessor in an external box. The i400 series card cage is mostly signal conditioning amplifiers with a little bit of glue logic. Internally, it is very quiet and has several microvolts of internal noise when doing low-level measurements, which is excellent relative to other data acquisition systems. The picture on the right shows the i430 card digitizing 0 volts at a 1000 sample per second rate on its plus minus 10 millivolt range with 2.5 microvolt RMS of internal noise. To further reduce noise, one can digitize more slowly and integrate each point. The picture on the left is similar, yet with 16 milliseconds integration per point at 60 samples per second, resulting in 0.2 microvolts RMS of noise. We also provide free strip chart recorder software called Instrument World that digitizes displays and save waves to disk. Alternatively, one can program in C or Visual Basic, or work with LabVIEW or DAISY Lab application software. Our top-selling product is the i555, which includes everything one needs to get started. It provides 8 differential voltage inputs, 4 voltage outputs, and 4 digital I/O, along with free strip chart recorder software. One can add cards as needed, yet in many cases, the i555 is sufficient. The i400 card cage system is available in 4, 8, 12, or 16 slots. Wiring boxes are available that easily bolt to the i400 series cards. The i510 is good with thermocouple sensors, the i511 provides BNC connectors, and the i512 works nicely with strain gauge sensors. And that brings us up to date in our company history. If you ever want to get in touch with me, please enter the GW Instruments website, click the Contact Us button, send a message to support, and put Hello Glenn in the subject line. Thank you for watching.